Hi, and welcome to the recap lesson for all the things we've done recently with basically everything binomial. So obviously everything we kind of use these buttons from the calculator. So start right at the beginning, which is where we had permutations and combinations. And if you're not sure on the calculator, we had NPR and NCR, which basically P stands for permutations and C stands for combinations. What's the difference? You should know is that if the order matters, if it matters who comes like first, second or third, then it's a permutation. So if the order matters, we have a permutation. And if the order doesn't matter, then we have a combination. So example of that I've used is like people qualifying for the next race. Whether they come first, second or third, they qualify either way. It doesn't matter which order they come in. Other ones is like friends sharing a meal. Doesn't matter who orders what, we're going to share it anyway. So let's just recap some basic questions. Okay, in a race of 16 people, how many ways can we have a first, second and third place finish? This is a permutation. Here the order does matter. It doesn't matter who comes first, second or third. So therefore in the calculator, all you need to do is 16p3. So 16 people, I want the top 3 finishers in first place, second or third, and it is a permutation. And you go on there. That gives you the answer of 3,360. Before we haven't quite done that, we've used almost like common sense, where you said we have 16 choices for the first place, then 15 for the second, and then 14 for the third. These do give the exact same answer. Okay, it's just sometimes a bit nicer to be able to use the permutation button. Next, the exact same question pretty much, but here we've got a combination. So we're 16, how many ways can we have a group of 3 finish in the top 3? So it's combination, so it'll be 16 combinations with 3. Again, go to calculator, type it in, and that gives us 560. And what we've done before is we've done the same thing, working out long way, where we had 16 times 15 times 14. That was for the top 3. Then we had to divide by 3 factorial. How many ways we can organise those top 3. But again, this is a much faster and cleaner way of doing it, really. Okay, a group of 4 friends order 4 different starters for themselves from a list of 10 starters. How many different choices do they have? So first question, is this a permutation or a combination? Does order matter or does order not matter? And here the order does matter. If I order a starter and you order a starter, then that's my starter. It's different if we each order each other's starter. So here the order does matter. It matters which person orders which starter. And if the order matters, that makes us a permutation. So you would type in 10p4, type in calculator, and that's your answer. Just tie a knot on that. The other alternative was they had 4 different starters to share. Here the order doesn't matter, because if I order one starter and you order another, we can both share them anyway, so it doesn't matter which person orders which starter. That makes it a combination, so you would then do 10c4. Okay, and that's it. Moving on, we have binomial probability. So this is fairly tough because it's almost one of those things where if you try and get your head around it, you can confuse yourself. My advice is basically look at the way I explained it in the previous video, look at the formula, and sort of convince yourself they're kind of doing the same thing. So we have this formula where we basically had x successes, which meant we had n minus x failures, and then we had to times those probabilities by how many ways we could organise it all together. So go through a couple examples. So basically all the examples fall into one of 2 main categories, basically where I just give you the information in maths talk and where you have a worded question. So here n is 20, because it's this number here. P is 0.03 or 3%, and I want 1 success, so x equals 1. So I use this formula, and that's all you need to type in really. Everything else can just go straight onto the calculator. So we have 20, choose 1, times p to the x, so probability is 0.03, and that's to the power of 1, which I don't really need, but never mind. Times 1 minus p, so that's probability of failure, which is 0.97. And if I succeed once out of 20, that means I must fail 19 times. Work it all out, that gives us roughly 33%. So that equals, so this thing here equals, probability of x equals 1, 0.336. So same idea of a question, but here it's a worded question. The odds of Maisie winning a game of chess is 0.75. If she plays 12 games, what's the odds of her winning exactly 6? So I'll do the same thing. I'm going to list down what n, p, and x are. So n is the number of trials, the number of whatevers. In this case, it's the number of games. So she is playing 12 games. P is probability of her winning, or probability of success. This is 0.75. And we want her to win exactly 6. And that is our lowercase x. And then just as a 4, we're going to plug everything into this formula. Again, no point writing anything down. We can just type it all straight in. We have 12 choose 6 times 0.75. That's a probability to the power of x. Then if that's probability of success, the odds of her losing a game is 0.25. And if she wins 6, then she must lose 6 because she's playing 12 games altogether. And that gives us about 4%. Okay, so in terms of the maths with this formula, you're doing very little maths. It's basically your main job is plugging it into the formula and recognising what these key values are. Just go for 2 more types of questions that also come up. So here the same question with Maisie playing her games of chess, but now I want her to win at least 10 games. Okay, when it's at least or at most or more than or less than, you've got to think what are all the possible numbers we could have. So if she's winning at least 10, that means she can win 10 games exactly, and she can also win more than 10 games. However, she's only playing 12 games, so the most she can win is 12 games. What you then need to do is then work out probability for each of these things one at a time, and then add them all together at the end. And so for each one, n is 12, p is 0.75. In essence, these 2 things never change, so you can just copy them across, and then work out each one at a time in your calculator, and then add them all together, and that's your final probability. I've also got the same type of question in basically maths form. So here, the first question we saw where n was 20 and p was 0.03. Our probability of x being less than or equal to 2. So the or equal to is really key. If it was just less than 2, that means there's only 1 or 0. But because it's less than or equal to 2, that means x can also be 2 as well as 1 and 0. And again, to work these out, you would just copy your n and p because they're not going to change no matter what your x is. Again, work all 3 of them out, add them all together, and that's your answer. Okay, moving on to the third topic, number 3 is the last one. This is binomial expansion. So this is how we expanded stuff inside brackets to very high powers. And again, it was all to do with combinations. So I said you've basically got some options. You could have 5x's, which would be x to the 5. We could have 4x's and a y. That would be x to the 4y. And we could keep doing this. We'd then have x to the 3y squared. We would then have x squared y cubed. We would then have xy to the 4. And lastly, y to the 5. And we then need to work out what number's going to go in front of these. So here, there's basically only one way you can organise 5x's. Okay. To type it in the calculator, you want to say how many letters we have, which is 5. This is combinations, because the order doesn't matter. We don't care where the x's and y's come, as long as I have the right number of each. And it's 5 choose how many y's we want. And I want to choose no y's. You type it into your calculator, and anything choose 0 is always 1. So that means you have one lot of x to the 5, which makes sense. There's only one way you can organise this. Next, for 4 x's and 1 y, that is going to be 5 letters, and I want 1 y. Type that in, 5 choose 1 is 5. Next, we want 5 letters, and we want 2 y's. So 5 choose 2 is 10. And you keep going down, and each time, basically, this number, how many y's we have, is going to get 1 bigger, because each time I have 1 more y over here. And you keep working it out, and that gives you all your terms. And then for a final answer, you would then basically write these how you normally see them written, one followed by another. Okay, we have already seen that before, so I won't spend too long talking about it. I'll just talk briefly about how questions can look a bit different and some slightly harder questions. So we can do quite high powers. Here I'm looking at like the power of 10. However, rather than you have to work out every single one of the 11 terms in total, we're just going to work out the first 3 terms. So I'm going to say my first term is where I've got all x's. So let's just write them out this time in long form so we can see what's going on. So I think that's 10 x's. I don't really mind too much if it's not. And again, the options I have is 10 letters and I want no y's. That's going to give us 1, so I'm going to have 1 lot of x to the power of 10. Again, the 10 letters, all of them x, so x to the 10. Next, I'm going to have a bunch of x's, and I'm going to have 1 y. So now it's going to be 10 choose 1. 10 choose 1 is 10, and I've got 9 x's here and 1 y. So it'll be 10 x to the power of 9 y. Keep going. Next one, I'm going to have 2 y's. So it's going to be 10 choose 2. 10 choose 2 is 45. I have 8 x's now, and I've got 2 y's. And I can keep going, but that's all I'm asked to do. We're only asked for the first 3 terms, and right here I have 3 terms. So we just say the first 3 terms are x to the 10 plus 10 lots of x to the 9y plus 45 lots of x to the 8y squared. Okay, that's all you need to do. So to make your life a bit easier, not have to work out every single term. Same thing with this. So I want the first 3 terms. Key difference here is rather than a y, we've got a 4. That changes very little. Okay, let's go through it anyway. So the first term is going to be all x's. 5 letters, so 5 x's. I have no 4s, so this number here is basically how many 4s, not how many y's now. So I've got 1 lot of x to the 5. Next I've got x, 4. So therefore it is 5 choose 1 because I have 1 4. That's going to give me 5x to the 4 times 4. So this 4 by the aim to be multiplied along with everything else. And whenever you get a question like this, you always want to multiply all your numbers together. So I've got 5 times 4. That's going to give me 20x to the 4. Okay, so a slight new step here right at the angle because we had a number. We have to times that number by the number that came out the front as well. Next term, we want 3 terms, so 1 more to go. It's going to be 3 x's and 2 4's. So it's going to be 5 choose 2. 5 choose 2 is 10. And it's going to be 10x to the 3 times 4 squared now. We work it out by BidMath. We have to do 4 squared first. 4 squared is 16, and then we do 16 times 10. So it's going to be